GCSE vectors on steroids. Now this question was actually submitted to me on the Reddit page, the Lungang Reddit page by GoGoNut6543. If you want to submit your own questions and get feedback from the community or myself, then check the link in the description and join the Reddit page, innit? So this right here looks like a crazy vectors question asked at GCSE. Whenever you see two lines crossing each other, I'm not going to say panic, but just know you're in for a bit of algebra. Okay, so it says that here we have a trapezium, we have these diagonals intersecting at P, we have the vector A and B, and it says the ratio of O to P, P to N is 3 to 2, find the vector A to X. Okay, so this is 3 and this is 2. Okay, given that, how'd you go from A to X? Now I did a question very similar, well, I've not attempted this question yet, but I did a question that looks very similar, which looked like this. It was something like this, and it asked you to work out what this ratio was. It was like ONNB or something like that. So you guys should watch that video where I'm going to do a very similar process, okay, with these kind of intersecting diagonals. So I'm first going to lay out how I feel I'm going to go from A to X. How am I going to go from A to X? Well, there's no direct pathway from A to X because I don't have O to X, okay? But I could just say A to X, I could go AOOX, okay? But then the problem with that is, how am I going to find O to X? To go from O to X, I'm probably going to go A and then A to X anyway. So I'm going to do the strategy I did in that other video where I'm going to say A to X is some extension of AP. If I can work out what AP is and just say you extend it out, you get to X. I'm going to call that extension K. Okay, A to X is some extension of A to P. Is it double? Is it triple? Is it 1.5, 1.75? I don't know. It has to be bigger than 1 though. So I need to figure out how I'm going from A to P. All right, to go from A to P, I guess I'll go A to O, O to P. So I'm going to say AO and then OP. OP. Now AO is easy. That's minus A. We're going against the arrow. Now here's an interesting one. O to P is 3 parts out of 5 of O to N. Okay? So O to P is 3 parts out of 5 of O to N. And we know what O to N is. A plus B. Let's expand. And simplify. So we get, what was this? This was AP, wasn't it? I'll just write the A's first. Even though it's negative, I'm just going to do it. So minus 1 plus 3/5 is minus 2/5. A plus 3/5 B. That's A to P. Now we can plug that in. We just need to work out what K is. Okay, so A to X is, multiply this by K minus 2/5 K, A, and 3/5 K, B. Now the question is, how do we work out what K is? And this is where I'm going to go back to what I said before about O to X. O to X is horizontal, right? If I can work out what O to X is, I know it only has to be a multiple of B. Because it's horizontal, we have a trapezium. These two sides are parallel. So if A to N is B, then this vector also has to be a multiple of B. So if I can work out O to X, I should hopefully be able to work out what K is. To go from O to X, I'm going to go OA, AX. OA, and then AX. And the good thing about that is I know what A to X is in terms of K. This should do it. This should help me work this out. Now O to A is just the vector A. And then we're going to add all this. So we get that minus 2/5 K, A, and 3/5 fifths KB. Factorize, so we get O to X is here we're going to get that coefficient of 1 minus 2 fifths K, A, and 3 fifths KB. Now, what did I just tell you guys earlier? I said O to X is horizontal. It's parallel to B. It means this should not exist. So all we're going to do is set that coefficient to be 0. So we have 1 minus 2 fifths K is 0. When you rearrange, it will become 1 equals 2 fifths K. And then we times by 5 divided by 2. There's our K value. Sick. Now we take that, we're going to plug into here, and then we're done. So therefore, A to X is minus 2 fifths of K, which was 5/2, A, and 3 fifths of K, 5/2, B. Here, these all cancel. We're left with negative A. Here, the 5's cancel. We're just left with 3/2, B. And that's my solution. So yeah, guys, let me know what you think. I would recommend that given this exam season, you share this with a friend who is taking the higher GCSE paper. It should help them out because vectors seems to be coming up in the final paper of 2015 because it's not been asked so far. So yeah, share it with your mates, like the video if you learned something new. Good luck with your final exams. Subscribe for more maths content. And if you are interested in my GCSE courses, then feel free to check out the description and your future A-levels. Nice.